I don't think we have time for questions now, so I'm just going to keep it rolling to introduce Tim Pastoor, the founder and CEO of Pastoor Science Communications and president of the Health and Environmental Sciences Institutes.
Good afternoon. We are, in fact, building something here, aren't we? We're here together to be in the room, and the folks on the webcast to actually think about what it is that we're about here, aren't we? And when we think about all of that wonderful data out there and all the statistics we can get into and all the toxicology we can talk about, it's fascinating, isn't it? But ultimately, we've got to think about why it is that we're doing what we're doing in gathering all those data together. And that's some of the things I'm going to be talking about in the next few minutes. Really, it's about the complex chemical world that we live in. Indeed, what we're trying to do is assimilate data that's going to give people, you can see there on the right, your friends, your family, the people in your community, a chance at understanding what it is that may imperil their health, and certainly, more importantly, what it is that would keep them safe. And so those are the fundamental ideas that we're about here, aren't we? And in fact, what we're talking about is risk, or really the flip side of that coin, which is safety. What we want to know is, can we be exposed to that chemical in a way that is not going to harm the health of ourselves, our family, our community? That's what we're really about. It's all about risk and it's all about safety, isn't it? So what I want to do is start with that concept and just talk about what safety and risk is really all about. We might have a different idea of what that is, but I would guess that most of the people in the room here understand that risk or safety is a function of hazard and exposure. So on the one hand, you have to understand what the toxicologists are saying, what kind of animal studies, what kind of epidemiology is going to say something about what adverse effects might happen. And in fact, I stumbled across this cartoon, and being severely addicted to Oreo cookies, I volunteered for the high-dose study. But we do that in toxicology, and as toxicologists, our job is really to find out what adverse effects could occur and at what dose level they might occur, at. The other part of that equation really is exposure. So it's not sufficient really to say something is neurotoxic, an endocrine disruptor, will affect the liver, whatever it happens to be. You have to know at what degree of exposure might happen in humans that might induce that. So the other part of that is exposure, and looking at that from all the different routes of exposure that could occur, from the skin, inhaling it, and so forth. This is obvious stuff to most of us that are in the room and on the webcast, but I think it's important to really start there and get an idea of where we are thinking about this. The National Academy of Sciences has been very much active in both of these areas, both on the hazard side or the toxicology side and epidemiology side, as well as on the exposure side. And they actually published a couple of different volumes late in the 2000s that I think most of us are familiar with, Tox Testing in the 21st Century and Science and Decisions, which kind of framed up that we had finally gotten to a stage where we had to do a little navel gazing. We had to think about what it was we were doing, and are we doing it correctly or not. Following on with that, there was exposure science in the 21st century and using 21st century science to improve risk-related evaluations, just published last September. Now, what these National Academy of Sciences volumes are really trying to point at is that what we're doing is building something. We're improving, we're moving on to something that's better. And that's exactly what the stimulus was for getting a group of over 120 scientists together to work on something called risk assessment in the 21st century, or as we paraphrase it, as Risk 21. So in the late 2000s, right around 2009, 2010, we were at a Society of Toxicology meeting. And I don't know, Norb, if you were there or not, but a bunch of us were. And I posed a question to the people in the audience. Everybody was standing up, everybody had a glass of wine, and everybody was happy. And I said, I want you to do a two-dimensional array here. I want you to either disagree with what I'm going to say or agree with it, and position yourself in the room accordingly, right down the middle of the room. Now, you can do this. You could do this at home in your living room as well, but in the room here, if you were to do that, where would you go if I said, we do a great job of human health risk assessment. Do you agree or disagree with that? Lubia would be over here. A lot of people would be, and in fact, in that room, most of the people were on that side of the room. We don't do a very good job. I stood there amazed by that, and then the next question I asked, or the statement I made, was, we do a great job utilizing our resources to do risk assessment. Time, money, animals. We do a great job of utilizing our resources. Where would you position yourself? Now that you're on that horizontal, where are you on the vertical? Do you disagree with that statement or do you agree with it? Think about where you'd go. Most of the people went that way. They didn't think we're using our resources very well at all. So here we were in a room with over 100 people all crammed in the corner over there. And all I said was, look, folks, we have to figure out a way from going from that quadrant over there to this quadrant over here, where we do a good job of doing risk assessments, and we utilize the resources properly to do that. So in the course of the last, it's about 8 years now, we've had over 120 people get together in various places in North America, Europe, and elsewhere to put out 8 publications describing a methodology to approach a risk assessment in the 21st century. We've also gone to 6 countries on 4 continents, and we've done had over 600 people participating in a workshop looking at the philosophy of how you approach risk assessment, how you acquire hazard and exposure information, and how you put that together in a meaningful way. I have to say, it's one of the most stimulating things about my career that I was able to go to places with some really, really fantastic people and work in groups like this, looking at why would you choose those toxicology data? Why don't you have better exposure data? Those kind of discussions are what really frame how you get better at what we have to do, which is risk assessment in the 21st century. Now, those 8 publications you can get online. They're all open access. They're all in critical reviews in toxicology. And on the left-hand side, what you see there is a series of publications that describe the essence of the roadmap and matrix. And we've got 2 case studies we used, which I might get to today. I don't know as I'm going to have time, but I will suggest that you go and read these for yourself. The ones over here are using mode of action in risk assessment, very detailed information, and we've got a couple of papers on cumulative risk assessment, so exposure to mixtures as well. How do you do this? I mean, we're not exposed to one chemical at one time. We're exposed to lots of chemicals all the time. How do you deal with that? And so we've written a couple of papers on that. And we've also looked at what I call the red-haired stepchild of risk assessment, which is exposure. I'll come back to that. We need better information on exposure. We just don't simply have that quite often, but we've written something about making rapid decisions. So what I'm going to focus on today is these papers on the left, which is really talking about what is the essence of what Risk 21 is all about. So you get an idea of what it is, and maybe we can begin that process of building something that is efficient. That's something that is philosophically appropriate, and on top of that is a way that we can communicate to our friends, families, and communities what the safety and hazard is of the chemicals that we're exposed to. So really, I get this question all the time. How is it different? There's a lot of different ways to do risk assessment, but it's fundamentally a very simple process. Just put hazard and exposure together, right? Well, that's not how it happens. Since the early 1970s, what we've been doing is developing data and producing those data to make decisions. And how do we do that? Well, typically the way we do that is what I call kind of a smorgasbord approach. We throw everything out there on the table, and then we pick our way through that until we find the data that we need, and then decide how it applies to a problem that we might have thought about, and then we make some decisions. That's the paradigm that we've been in. So coming out of the agrochemical pesticide industry, I know this for a fact. I mean, the 40 CFR and OECD guidelines are huge. It's a tremendous amount of data in animals, time and money that gets put into that and gets reviewed. And then we pick through that and find a no effect level from that. information and go about trying to apply that to a problem. Well, the new paradigm that we're trying to get across now is something that, Lance, you were talking about earlier today, which is problem formulation. What's the question? You can't get an answer until you start forming your question. So really, we're trying to get folks focused on this idea of identifying the problem before you go about trying to acquire data, and then developing your conceptual model, moving on to targeted data development or tier-wise or tiered data development. And then you can see the return arrow down on the bottom. The reason that that's there is that it's not over. Once you get to that end, you continue to develop data as necessary and ask those same kind of questions. So the principles that are fundamental to RIS 21, and later on you're going to see a very nice visual matrix that Katie's going to talk a bit about how you do this as far as communicating. But ultimately, it's the guts behind it. It's the kind of information that you have in your phone that nobody ever sees that makes it so valuable. It's the philosophy behind what you're trying to do. And those fundamental principles are the following. It's problem formulation based. I just said it. And Lance, the quote you're going to have to help me with is, it's better to have a good answer to an approximate answer to the right question rather than a... Very good, you get a straight A. But that's what problem formulation is all about. You got to ask the right question to get to the right answers, and that's important. The other is exposure driven. Now, as a toxicologist, this is very difficult for me to say, that it's not toxicology that takes the forefront. It should be exposure. How much are we exposed to? If it's a closed system, very little exposure, you may develop your toxicological data differently than if it was a high exposure, low toxicity compound. You have to think about that, and exposure leads the way. I had one toxicologist say to me that if you used human exposure to various chemicals and you set your dose levels accordingly, he said, we might not get any effects. I said, well, if that's the case, when you use exposure-driven analogies, you might develop data that's more appropriate for the situation and answer the question that you're trying to pursue. Third point there is it's prior knowledge. In other words, why do we treat each chemical as if it was a new entity? Why can't we do what we're talking about today and tomorrow morning, which is integrating data to make decisions? Quantitative structure-activity relationships, we know about that, but read across. Lots of philosophical approaches to the science that we have to pay attention to. That's very, very important. And finally, and this is a term that we coined in the process of working our way through the publications, and that's that what you want is enough precision to make the decision. And again, I'll pick on Lance and say that what we're talking about here is narrowing your field of view to the point that's necessary. How much data do you really need to get an answer that is precise enough? And that's the important part about it. And then ultimately, we've got a flexible, transparent, and visual system that's fit for purpose for the question that you've asked. Now, let me show you what it looks like. Very simply, it's this way. 4 steps, and we start with step number 1. Step number 1 is problem formulation. I talked a bit about that. You'll notice the exposure in toxicology is in an inverted triangle. That means you're using less resources at the bottom and more at the top to determine more and more as you go through a tier-wise approach to get enough precision to make a safety decision. Ultimately, that's the fundamental principles there, and it goes on to developing this into a visual matrix that I want to show you that is so very valuable in communicating the risk information that you have. Let's take a look at this very quickly. So we have 2 axes. They're on log-log plot here, which you notice on the y-axis is inverted. It's toxicology and exposure on the x-axis. The y-axis here is inverted because we usually think of toxicity as being high toxicity. What are the numbers in that situation? The numbers are low. So we inverted it, and by doing so, we can say that as you get a high toxicity material with low exposure, you might be in this green area, which just like when you go and buy a refrigerator at Lowe's or Home Depot, You're going to know whether it's an energy efficient or not based on its green to red sort of span. It's very, very visual. So that visual aspect is very important as well. Another feature of it is that we insist that this estimate of exposure and estimate of toxicity be like for like. So that when you have toxicity studies that are done in a feeding study, milligram per kilogram per day, you should be doing an external exposure in milligram per kilogram per day as well. If you have assays that have been done at micrograms per liter, you should be looking at plasma concentrations in micrograms per liter, or indeed at the target tissue. You need to use like for like. And let me say one other thing about like for like. Each one of these plots should be within the duration of exposure that the human would endure. So you can have acute data on here, you can have intermediate term or chronic data, but it should be like for like. Those are important aspects of how we use RIS-21. So we plot the exposure range. Again, it's not precise necessarily. We sometimes think it is, but it isn't, and it comes together into a risk box. What does that give you? It gives you an opportunity to then take a look at various aspects of chemicals. Now, I've just plotted a whole bunch of different chemicals up here. What do you see? What is the worst chemical on that list up there? E. What is the least problematic? A. It's well into the green area. F as well. If you look at F, what kind of data do you think you probably ought to need to get better precision? Exposure data. Very easy to see. What kind of data would you need if it were B? Tox data. So it very visually shows what you have here. If this was a whole bunch of different chemicals in one place, then what you'd be dealing with is saying we need to prioritize our attention on D and E, and A and F are something we can deprioritize or put on the back burner for later. It's a very easy tool to communicate. Okay, so other ways that we can use this. You can use it with a TTC plot, which doesn't have the toxicity value. It's just against an exposure value. You can take a look at the no effect level here and put uncertainty factors around that. In this case, there's a 100-fold uncertainty factor, and plot that. You can look at individual values, as we did in the 20 chemicals in water case study. We said which ones are the ones that are most problematic, very similar to what I showed you before. These would come out as problematic and these less so. You can prioritize and communicate that information very, very nicely. On top of that, you can look at one chemical, and you can look at different exposure scenarios, indoor, outdoor, urban or outdoor, rural, and you can take a look at the different human exposure levels that you might get in that situation with one chemical. Lots of different applications to it. In addition to that, and something Katie, I think, is going to pick up on later, is that we want somebody out there to come and show us and work with us on how you take probabilistic distributions of exposure and toxicity data and put those onto a matrix. What would that look like? Just imagine what that would look like if you took each one of those and blended them together. You have effectively what you have is an isoprobe. And you begin looking at the probabilistic aspect of what you could have as a risk or safety communication tool. We have a web page, RIS21.org. I encourage you to go there. You can actually go to the RIS21 tool. You can put your data in here. You can change the axes. You can change the diagonal on here to a margin of exposure of 1 or 10 or 100, whatever you want. Lots of flexibility to this, and most importantly, you can put in your problem formulation from the beginning. So it'll walk you through all of that. And along with things like what you were just talking about, Chris, about Hawk, all of these kinds of tools, we've got to find a way to blend them together so that we can use them in a way that conveys that kind of risk and safety to humans. Those data are going to come from a lot of different sources. Right now, RIS-21 doesn't plow those in. It has to have an interface that will work in that fashion. Lots of information has to be acquired. It has to be parsed. It has to go through systematic review, just like Chris was saying, before you can begin using this. But it gives you a very visible way to communicate that information. I'd like to end with one last thought here. That thought comes from my state of North Carolina where I live. We have a problem with something, and this is going to be politically sensitive, so I'm going to say it anyway. We have a problem with a chemical in the water called Gen X. I have no connection with Chemours, Gen X, or anything else, but I will tell you, it's really difficult for me as a toxicologist to find information on exposure. I found some, not a whole lot. Toxicology information, I'm sorry, EPA, but I can't get information very nicely from where I've gone. I'd like to go there and find the values, the backup information. Maybe someday Hawk or some other database will help me with that. But I have to say that when I look at Gen X, how am I going to make a decision and as a professional communicate to my state individuals, my friends, my families, and say, you have a big problem or you don't? How do I do that? Maybe Risk 21 is one of the solutions to help us with trying to do a better job of communicating risks. Thank you very much.